Hello and welcome to this video. This is part 2 of Introduction to Networking, and we're going to continue talking about some concepts that are important to understand. Well, there is different data transmission or ways to transmit data. One of the ways is connection-oriented. Connection-oriented, it's better described or exemplified like the telephone system. You create a point-to-point connection between the sender and the receiver, and once that is created, that link is created, communication starts. Now there is also connectionless services, and that's more related to, it can relate to an example of the postal service. You send a letter in the postal service and you hope that it reaches destination, but you don't hear from the letter that you sent until probably the end, and the end result. So you don't get any confirmation until the end. So these are the two different services, or two different ways to transmit information in a network. Now, the difference between the two, well, besides the obvious one that I just described, is that one offers a more reliable way to transmit data, and the other one offers more speed. The connection-oriented, of course, offers the reliability, since you are having constant feedback in your connection. If something goes wrong in the connection and a package is lost or data is lost, you will realize it immediately, and actually it will also try to recover immediately. So it's generally much more reliable. Instead, connectionless services or data transmissions are less reliable, because again, you send a letter, and if it gets lost, you probably won't know until much later, so you don't have immediate an immediate notification of the loss. And also the good thing though is they are very fast, because they don't need to spend time doing that feedback. Now, examples, like real life examples of these two ways of transmitting data or applications could be when you send a video, or when you are watching a video online on YouTube, or a streaming video. Streaming video really is a connectionless service, and that's to improve the speed of this large amount of data that is sent. And that's why sometimes when you are watching a live transmission, you will lose the signal, or you lose the image, and that's because just the packages are lost and are not recovered, since it's a connectionless service. Now there is another concept that you have to understand, and those are called the primitives or service primitives, and those are simply fancy names for operations. And these are the operations that happen especially with these two kinds of connection or connectionless services. For example, the listen, the connect, receive, send, and disconnect are the service primitives that are, or messages that are interchanged between the sender and the receiver of the data. Now, this is an example of connection-oriented transmission. You see on the right you have the server machine, and on the left you have the client machine, and they are exchanging different packages. I call packages data, okay, zeros and ones, grouped in sub-series called packages. So you see the first one marked with number 1 is the connection request. So the client needs something, needs some data from the server, and it sends a request. The server replies with an ACK message, which stands for acknowledgement, and then the transmission of the data starts. The client requests the data, and the server reply with the actual data. This step 3 and 4, repeats itself until the information that needs to be sent and received is over, and the client sends a disconnect message or package to the server, and then the server replies with a disconnect message, and this concludes the communication. But you can see how a connection-oriented service really establishes that connection and also maintains it with a series of ACKs reply messages. This is why it's really called connection-oriented. the connection is maintained throughout the entire transmission of the data. If this was a connectionless example, you wouldn't have those acknowledgement and packages that go back and forward. Now, there are two different network architectures or reference models in networking. The most, these are the most used ones, are the OSI and the TCP/IP. And the OSI is called the Open System Interconnection, and again, it's a reference model that was created many decades ago. It was the first one created. Its main purpose was to first isolate the complexities of networking into different subsets called layers, and by doing so, it's easier to understand, explain, and implement all the functions and operations that a network has, which are quite a lot, as you can see. So what happens with the OSI model is that actually right now it's not in use, but it's used more academically to explain, networks, because it's considered more thorough and easier to understand than the TCP/IP model. I will tell you more about this in a little bit. So in the OSI model, the model itself came before the protocols existed. So that this makes this model really universal, not tied up to any specific protocols. Okay, and it also did a great job to make distinction between three different concepts, which are services, interfaces, and protocols. Okay, and services, like you see here in the slide, is what the layer does. Okay, not how it does it, but what the layer actually does, each of the layers. And the interfaces are how to access, these services, and the protocols are how to do the job. So the OSI model really does a great job describing these three concepts, and also to explain networking in general. Now, the TCP/IP reference model stands for Transmission Control Protocol, Internet Protocol, and it was created much later, okay, with the creation of the internet, and it was really created mainly to fulfill the need to explain the internetworking, or also internet networks, something that the OSI model doesn't do well. So in the case of the TCP/IP model, the protocols came first. So the protocols were created before the model itself. So you can see here the problem. It's more specific and tied up to internet networks than the OSI, which is more generic. That's why it makes it more specific, and the OSI is better to explain networking. There are more differences, but these are the most important. Just remember, the OSI it's not in use right now, other than to explain the networking, which is very important actually. And TCP actually is in use, but it has its problems too as a reference model. So let's talk a little bit more about the OSI first. The OSI has 7 layers, as you can see here. Now, the easiest way to remember these layers is something I read in a book, and that's by remembering this phrase: please do not throw salami pizza away. And P stands for the physical layer, D for the data link layer, N for the network layer, T for the transport layer, S for the session layer, P for presentation, and 7 A for application. So please do not throw salami pizza away. If you remember this sentence, then you can remember all 7 layers of the OSI model, which is important, especially if you are in college or taking a network class, and also to understand networks in general. So I'm going to describe each of these layers very briefly, but first I want you to notice that in this figure here you see different arrows going from protocol to protocol. Okay, the right side represents host P, or a computer, B, and the left side is computer A, and they are of course transmitting data, and they are using the OSI model. So as you can see, there are arrows that go vertically from top to bottom or from bottom to top. You see there's two different sets of arrows, and that indicates the flow of the data. The data in the reference model goes from, let's say a host A has to send something to host B. Well, it starts all the way to the top, and it goes all the way down through the layers until it reaches the physical layer, and then it goes through the other hosts until it reaches its final destination, host B, physical layer, and then it goes all the way up. And this is how the data is transmitted from one host to another, passing through every single layer in each host. Okay, so also you can see that there is like a rectangle in the middle. Okay, and that's because layer 1, 2, and 3 are actually in charge of communication between its neighbors. So they really see only their immediate neighbors. When from the transport layer and up, the communication takes place really point to point, or from the sender to the receiver all the way. So the physical data link and network layers only deal with its immediate neighbors, okay, in the chain of transmission, but the transport, session, presentation, and application actually deal with really true end-to-end communications. And this is kind of important to remember. So this is a brief description of each layer. So let's go through it quickly. The first one is the physical layer. This is the easiest to understand. It's the one that controls the transmission of the bit stream. Okay, so the zeros and ones, and this is the layer that takes the responsibility of actually physically sending those zeros and ones, and or those electrons, so to say. And this is the easiest to understand, and the different devices are besides the multiplexers and repeaters, are also the cables. And when you study the physical layer, you have to study all the different transmission cables that you use, like coax and the different, for example, if FDDI, that stands for fiber optics, the different fiber optic cables, etc., etc., etc. The second layer is called data link. Okay, and this is the layer that simply, first of all, is divided in two, and this division was done later on. And the first sublayer of this layer is the media access control, MAC, very easy to understand. And this layer or sublayer controls how a network or computer gains access to the data and permission to transmit it. So in other words, this sublayer, the media access control, regulates who gets access to the media when. It's like a light in the street, in other words, who can get to use the media, who has to wait. And because of this, of course, we have the logical link control, or LLC, sounds like a corporation, so it's easy to remember. This sublayer controls the synchronization, flow control, and errors checking of the frames. By the way, in the data link layer, the data that is manipulated there is labeled or called a frame. Okay, in the physical layer, it's simply called a bit, at 0 or 1. But in the data link, it's called a frame, just to differentiate the packages between each layer. They have a different name. Now, devices in the data link layer are switches, bridges, and routers. And protocols, okay, are Ethernet, point-to-point protocol, and HDLC. These are some examples, okay. The next layer is the network layer, one of my favorites. And this is the one that establishes, maintains, and terminates network connections. Okay, it handles traffic management, including addressing, routing, switching, forwarding, etc. So, in the network layer, one of the most important things that the network layer does is routing. So, it's really the layer that actually takes the package which is actually called a package in the network layer, series of zeros and ones, and send it to its destination. And for that, it uses the the IP address system, okay, and that's why the protocol that you see there in the network layer is IP and IPX and NetBEUI and NWLink, because these are the protocols that really make possible the routing of a package on the internet, for example. And not only that, also in the network layer, it is responsible to find the fastest and closest route for this package, so it doesn't take forever for one package to reach another one. Imagine this task on the internet, all these routers are doing this, and sending packages between each other and calculating which one is the faster and closest route, and many times also the cheapest route. Sometimes it's involved, cost is involved too. The next layer is the transport layer, layer 4, and this provides transparent transfer of data between end systems, and insulates the layer 5 to 7 from the complexities of layer 1 to 3. So it's responsible for end-to-end error recovery and flow control, and ensures complete data transfer. I'm just reading here, but it's the best explanation, really. The transport layer is like the glue between the 3 layers on top of it and the 3 layers below it. And because it's the first layer that really it's end-to-end, okay, it is in charge of error recovery, flow control, between these two ends. And this is very important, okay. Device is a gateway, and by the way, a gateway can be normally a computer, a server, and the protocols are IP, IPX, and pretty much the same ones that in the network layer. So the next layer is the session. The session layer really establishes, manages, and terminates connections, okay, between applications at each end. So again, this is another end-to-end protocol or end-to-end layer, and that has end-to-end protocols, of course, and allows 2 applications to communicate over the network by opening a session and synchronizing the involved computers. So this is very important, okay, and that's why it's called sessions, because what it does is create sessions, okay, point-to-point sessions. Now, and of course, it's responsible of managing those sessions, opening and closing. Now, the next layer is the presentation layer, which really is the one in charge of formatting the data to be presented or displayed, okay. It also is in charge of encryption and different things. The easiest way to see it is by looking at these protocols. You have HTTP, FTP, Telnet, SMTP, all these protocols that we use on the internet, really, and that normally users have more access. For example, when you program a web page, you use HTTP and to send that page, or FTP to send a package, or a file, or Telnet to create a point-to-point transmission, or SMTP to send an email. So these protocols, probably if you have been using the internet for a long time, you will be familiar with. And the presentation layer is the one that format the data and prepares to be shown to the end user, okay. Now the final layer is the application layer, which provides services directly to user applications, okay. This is really what we see, and identifies communication partners, identify quality of service, considers user authentication and privacy, and etc., etc., okay. So the different protocols are the same, or many kind of coincide with the presentation layer, because they kind of work together, these two layers are directly neighbors, so they kind of work very close together. So this is it for the 7 layers of the OSI model. Again, the OSI model is the best to really understand networks, and it isolates all the complexities of networking in different layers to make understand of networking simpler, and also to standardize the different protocols, what they do, and where should they be placed in context to networks. Well, I hope you enjoyed this video. And stay tuned for part 3 soon. Thank you so much.